So the method of sections is a way for us to analyze trusses without having to solve for the internal forces of every member in the truss. And so if you're looking for just the internal forces of a few members, you can use the method of sections to find those internal forces faster rather than the method of joints, which requires you to solve for every member's internal force. And so that's what we're going to go over in this video, and I've written all those steps down in the description. If you find it helpful, hit that like button and don't forget to subscribe. So the first step we're going to do in the method of sections is we are going to decide on how we are going to split the truss, and that will depend on the members whose internal forces you are trying to find. And so I have up here an example problem truss that I'm going to go over in another video. You can check out this link if you want to see an example problem with this. But if we are trying to find, say, member BC, its internal forces, we might cut it along the middle. And the next thing we want to decide is which side of the truss we are going to keep. We cut it down this way, so we can either keep this side or this side. And it doesn't actually matter which side you keep, because remember that if the truss is in equilibrium, all of its sections will also be in equilibrium, no matter how you cut it. And so if we're going to keep this side, we would need to solve for the reaction forces first before we cut it, so that we could apply these loads to the truss as a whole. But if we're going to keep this side, we wouldn't need to solve for the reaction forces, because really once you cut it, the internal forces of those members act as external forces, and that's how you can solve for them, because they will keep the truss in equilibrium. And so after you cut it and decide which side you're going to keep and solve for the reaction forces if they are involved in the side of the truss that you kept, then you'll need to draw a free body diagram of the section that you've kept, with your internal forces of the members drawn as unknown forces. And so then you can start using equilibrium equations to solve for those unknown forces that are your internal forces of those members that you're solving for. And the key equilibrium equation that you're going to use in the method of sections is moment equilibrium. And so in the method of joints, you're mostly using the sum of the forces in the x and y direction. But in the method of sections, you are going to use the sum of the moments. And so you're going to be summing moments about different points where you can cancel out as many of those forces as possible to be left with just one point that is an unknown force, so that you can solve for it. And you're going to sum moments about different points to find different forces. And so you can use some of the forces in the x and y directions if it ends up helping you. And in the example problem, we will do that to solve for the internal forces of this truss, but for the most part what you're going to be using is the sum of the moments. And so that's what you'll do. You will sum moments about different points, and those points can even be off of the truss. And that's what threw me off at first when I was learning about the method of sections. But you can sum moments about points that are off the truss. Say if we cut it down this way, we could sum moments about point B or point A or point G or point F, or even a different point that was, say, over here. The thing you need to know is how far away it is from those other forces, so that you can know what your moment arm will be. But those points don't have to be on the part of the truss that you kept, and that's important because you probably will have to sum moments about a point that is not on the truss or on the part of the truss that you kept. And so that's basically how the method of sections works. And if you want an example problem going over this, you can click on this link to go to an example problem, or those links will be at the end of the video and you can click on them. And so I hope you found this helpful. If you did, hit that like button. If you have any questions or suggestions, you can leave them down in the comments. And if you're new to this channel, my name is Preston Palmer, student engineering, and my goal is to help other engineering students like me better understand engineering. So if you want more videos like this, please subscribe.